To quickly recap our discussion from our last class, we were discussing that as part of fiscal policy, the government could raise its spending in order to increase aggregate demand in the economy, in order to narrow any recessionary gap, correct? Now, we said that there were two effects of this, a direct effect and an indirect effect. Now, the direct effect is simple to understand. Government spending is a part of aggregate demand. So if G goes up, aggregate demand goes up right away. So that is the direct effect. But there is an indirect effect, correct? And how does the indirect effect work? The increase in government spending makes its way into the pockets of households, right, who will then increase their consumption spending. So there is this indirect effect like this, causes an increase in consumption spending, which then causes an increase in aggregate demand. So you have a direct effect and an indirect effect. Now, the indirect effect can be much bigger than the direct effect. Hence, you have a multiplied effect of the increase in government spending on aggregate demand. Now, how did we work it out in class last time? Well, let's say that the government, say that G goes up by $1. What is the effect on aggregate demand? What's the change in aggregate demand? The triangle, of course, is the universal symbol for change. Well, how would we calculate this? Well, first, the direct effect. The fact that government spending has gone up by $1 means aggregate demand's gone up by $1 because G is part of AD, correct? But then we have the following happening. This dollar will make its way into the pockets of, let's say, the construction crew building the Hoover Dam, right? Remember the 1930s when FDR greatly expanded government spending, right? Now this money goes into the pockets of workers, and what do they do with this extra income? They spend, not all of it, but the marginal propensity to consume part of it. Is that right? So we have something called the marginal propensity to consume, which I'm going to assume is about 0.9, okay, for the states. And so these workers who receive this dollar of income will spend 90 cents of it on bread from the baker. Now this becomes the baker's income, 90 cents. And what does the baker do with it? In turn, he spends the MPC portion of this increase on meat from the butcher. So the next increase is going to be 0.9 of 0.9, 90% of 90 cents. Correct? And then there will be a further increase after that because the butcher will buy something else from somebody else. The increase in the butcher's income is 81 cents, correct? But he will spend the MPC part of that increase on, let's say, produce. And so you have a further increase then. And this goes on forever. And as we discussed in class, this here is a converging geometric series to infinity. It's called a converging series because the numbers are converging to 0. Each number is smaller than the one that came before it, right? Now, there is a formula for adding up this series. What's the formula for adding up this series? It's the first number of the series divided by 1 minus the factor of the series. Now, what's the factor of the series? The factor of the series is the number that you multiply each number of the series by to get the next number of the series. In other words, let's pick this number of the series. What do we multiply this by to get the next number? 0.9. Am I correct? So you multiply each number of the series by 0.9 to get the next number, correct? So in our case, then, the factor of the series is 0.9. So using this formula will give us the following. It will give us 1, which is the first number of the series, divided by 1 minus, what's the factor of the series? The factor of the series is 0.9. 1 divided by 0.1, which is $10. So when you add up this geometric series to infinity, you get $10. So basically then, in terms of this diagram here on top, what's the direct effect? The direct effect is $1. What's the indirect effect? The indirect effect is $9, making a total of $10. Right? So you have this big multiplied effect of an increase in government spending on aggregate demand. Now this fraction here, what is the general form for it? What is the more general form? The general form, of course, would be 1 divided by 1 minus the MPC. It just so happens that we've chosen 0.9 as the MPC. 1 divided by 1 minus the MPC. And this thing has a name. It's called the government spending multiplier. It's 1 divided by 1 minus the MPC. Right? Okay. Now let us say that we have a case where the government is increasing its spending, not by $1, but by some other figure. Let's say $125 million. Okay? So let me give you this little math problem to do. So math problem is, first I'm going to give you a value for the MPC. I'm going to say MPC 0.6. Okay? And next, G goes up by $120 million. Could you calculate the change in aggregate demand? Now, first, let's look at these numbers carefully, make sure we understand them. What does this 0.6 mean? Could you explain this 0.6 to me? Could you give me a sentence that involves 0.6 that explains to me the meaning of that 0.6? Anybody? What's the meaning of the MPC? Pardon me?
The worker savings?
Savings? No, certainly not. The MPC is how much they spend of every dollar increase in their income. Is that correct? That's what the marginal propensity to consume means. We're not talking about the marginal propensity to save. We are talking about the marginal propensity to consume. What does propensity mean? The English word propensity. I have a propensity for something. It means I have an inclination to do something. I have a propensity to take a walk after dinner, for instance. Do you see what I'm saying? Marginal propensity to consume means your inclination to consume. What portion of an extra dollar of income would you spend on consumption? That's what the MPC is. So this number indicates that consumers or households would spend $0.6 of every dollar increase in their income. That's what that 0.6 means. Is that correct? Because that is the meaning of the MPC. Right? Are we all clear with this, what the MPC means? So how do we figure out the change in aggregate demand in this case? Well, just bear in mind that a single dollar increase in government spending causes a 1 divided by 1 minus MPC change in 80. because that is the value of the government spending multiplier. Is that correct? Let's go back to this. What does this government spending multiplier mean? What is the meaning of the government spending multiplier? This would be the change in aggregate demand from a $1 increase in government spending. Is that right? That's what the government spending multiplier means. That's what the sum of this geometric series to infinity gives us. Is that right? So what the government spending multiplier is, it is the change in aggregate demand that results from a $1 increase in government spending. But now in this case, in our question, we have a $120 increase in government spending. But that's easy to deal with because $120 million are simply 120 million single dollars. Am I correct? And each of those dollars will have what effect on AD? Each of those dollars will have this effect on AD. So what would be the combined effect of a $120 million increase? Wouldn't it simply be this times 120 million? Wouldn't that take care of it? Do you follow me? So we basically calculate this. So this would be 1 divided by, what's the value of the MPC in our case? 0.6 times 120 million, which happens to be 1 divided by 0.4 times 120 million. And you can get rid of the decimal if you like, if you're doing this by hand. So what's the change in aggregate demand? The change in aggregate demand is plus 300 million. What's the purpose of this plus? This plus indicates that this is an increase in aggregate demand. Positive changes are increases. Negative changes are decreases. So we have a formula that we can now apply. And what is that formula? The formula that we can apply to these situations is the change in AD equals change in government spending times government spending multiplier. Right? Now in our story here, what's the change in government spending? Government spending is going up by 120 million, which means that the delta G in our story was how much? Plus 120 million. I should have put a plus there to make things clear, because this is an increase in government spending. Is that right? What if I give you another problem where I say that G goes down by 20 million. Government spending can go down as well, you know. It can go up, it can go down. Now, could you calculate the effect on aggregate demand of this decrease in government spending? Well, if government spending decreases, well, the entire geometric series to infinity that you see here would work in a negative direction. Am I correct? Because now the government here would reduce its spending by $1, right? So you would have minus signs in front of all of these. Am I correct? There would be a minus here, a minus there, a minus, minus. Do you understand that? Because if the government spends $1 less, what happens? Aggregate demand immediately falls by $1 because government spending is a part of 80, right? But then those workers receive $1 less of income. What do? They therefore reduce their purchase of bread from the baker by 90 cents. The baker reduces his purchases of meat from the butcher by 81 cents. Do you see? So that'd be a sequence, but it'd be a bunch of negative numbers. Am I correct? Are you all with me here? So how would we apply that formula then to deal with decreases in government spending? Well, all we do is we use this formula here, and this formula will give us what? The change in government spending now is what? Tell me. What is it going to be? Government spending is going down by 20 million, minus 20 million. I put a minus there because the change in this case is a negative change. Am I correct? And then I simply multiply by 1 divided by 1 minus 0.6. And what does that give us? Minus 20 million times 1 divided by 0.4. And you could write this as negative 200 divided by 4, which is negative 50 million. Negative 50 million. So in other words, how would you put that in words? You would say AD decreases by $50 million. If the government reduces its spending by $20 million, in this example, aggregate demand should decrease by $50 million. Now, in terms of our ADAS diagram, what would happen in that case? If this is our ADAS diagram, if I draw an AD curve like that, this is GDP, this is the price level. How would you show a decrease of aggregate demand of $50 million? How would you show that? A shift to the, exactly, a shift to the left, a shift like this. Am I correct? And what would that horizontal distance be? Horizontal distance. Well, that is the decrease, right? And that horizontal distance is going to be how much? Right? That's the decrease in aggregate demand that results from this reduction in government spending. Okay? I'm now going to use a term that I haven't used before, and that is expansionary fiscal policy versus contractionary fiscal policy. Now, previous question, government reducing spending. Would that be expansionary or contractionary? Let me explain what the two terms mean, expansionary, contractionary. Expansionary means designed to expand AD, hence equilibrium real GDP. Contractionary means designed to contract AD, hence equilibrium GDP. Expand, contract. Correct? So when there is a recessionary gap, should the government pursue expansionary fiscal policy or contractionary fiscal policy? Well, when there is a recessionary gap, don't look at me so blankly, come on. When there is a recessionary gap, what kind of fiscal policy should the government pursue? Expansionary or contractionary? Would the AD curve be shifted to the right or left when there is a recessionary gap? To the right, of course. To the right, because that's how you narrow a recessionary gap. Am I making sense to you, or am I just talking Greek at this point? Because if my words don't make sense to you, you're not studying hard enough, frankly. What is the relevant diagram? I'll quickly remind you of this. This here is equilibrium GDP. This here is YF, potential GDP or full employment GDP. That gap is called the recessionary gap. That's an economy in recession. How do you get rid of this gap? You get rid of this gap by shifting the AD curve to the right. Am I correct? Because if you manage to shift the AD curve all the way, if you manage to shift the AD curve all the way to here, wouldn't you have gotten rid of the gap? Because when the AD curve shifts all the way there, what becomes the new equilibrium? The new equilibrium becomes this. And what becomes the new equilibrium GDP? YF. Is that correct? And now the gap is gone. Am I right? Do you follow that? So this is what's needed when there is a recession. When there is a recession, the government has to take steps to cause the shoppers, the four shoppers, or some of them, to shop more. Correct? Demand in the economy needs to be stimulated. The AD curve needs to be shifted to the right. And that's what expansionary fiscal policy would do. So in a recession, what kind of fiscal policy is called for? Expansionary fiscal policy. Fiscal policy designed to shift the AD curve to the right. Correct? Now in my previous question, we had a decrease in government spending. Is that right? Now what kind of fiscal policy would that be? Expansionary or contractionary? Contractionary. Right? Now you tell me, when would contractionary fiscal policy be called for? Would there be any need for contractionary policies? Yes, inflation. That is correct. Now, let me talk about this for a second. Inflation. Now you notice here that when the AD curve shifts to the right, what happens to the equilibrium price level? The equilibrium price level used to be this, and now it is that. Am I correct? So what does this tell us? This tells us that when there is a big increase in demand in the economy, the price level rises from P star to P double star. This rise in the price level is called inflation. Is that right? So what might cause inflation? By the way, there is a name for this kind of inflation. This is called demand pull inflation. It's inflation caused by an increase in aggregate demand. Demand pull inflation. How does the government set about fighting inflation? If the government, remember, inflation is a bad thing. Right? When we speak about three macroeconomic goals, what are the three macroeconomic goals? To have low unemployment. Next, to have low inflation. And third, to have a high rate of economic growth. Right? So the government would like low inflation. If there's high inflation in the economy, the government might take steps to reduce AD, or at least prevent AD from expanding too rapidly. Am I correct? And so in that case, what kind of fiscal policy would be called for? Fiscal policy that puts the brakes on any rightward shift of the AD curve. Am I correct? And what kind of fiscal policy would that be? Expansionary or contractionary? Contractionary. Right? So contractionary fiscal policy is called for when there is high inflation in the economy. The government sets about reducing its spending in order to prevent the AD curve from shifting to the right too rapidly, because that's what causes the equilibrium price level in the economy to rise, inflation to happen. Yes? Now, we can start to talk about taxes, because remember, fiscal policy has two components. Fiscal policy is policy about government spending and taxation. We have discussed how this works. We've discussed the government spending multiplier. Let us now discuss the tax multiplier. So my story now is going to be as follows. Let's say the government raises taxes, T for taxes, by $1. Now, would this be expansionary or contractionary fiscal policy? Would this be expansionary or contractionary fiscal policy? A rise in taxes. Expansionary or contractionary? Does it shift the AD curve to the right or left? Left, exactly. Left. Why? Because when the government charges you an extra dollar of taxes, you have less income to go shopping with. Correct? And so the AD curve will shift left. So this would be contractionary policy. Right? So this would be contractionary policy to be used when there is fear of inflation in the economy. But let's see how this would work. Let's again calculate the change in aggregate demand that would result from this. When the government takes away takes away $1 more in taxes from you, the households are left with $1 less to spend. Your income's, in a sense, gone down by $1. Right? Now let's say that the MPC again is 0.9. Now if you have $1 more of income, what happens? How much of that dollar do you spend on consumption, given the MPC is 0.9? 90 cents, right? But now I'm talking about a reduction of $1 in your income. A $1 reduction in your income. By how much would you now reduce your consumption spending? It works the same both ways, you know. If you have an extra dollar of income, you spend the MPC part of it, correct? If you have $1 less of income, you reduce your spending by 90 cents. Do you see? Now, you might ask, well, how is this going to happen? If your income goes down by $1 and you reduce your consumption spending by only 90 cents, what's happening here? Well, of course, what's happening is you are beginning to dissave, right? Your income's gone down by a certain amount, but you've cut your consumption by less. And that can only happen if you dip into your savings or if you borrow. Am I making sense to you? But this works both ways. The MPC works both ways, is my point. If you have an increase in income, you spend 90% of that. If you have a reduction in income, you reduce your consumption by, again, 90% of the decrease in your income. Right? So what would be the change in AD then? The first change? You would buy 90 cents less of bread from the baker because the MPC is 0.9. So the baker has 90 cents less of income now because you have spent 90 cents less on his product. So the baker has 90 cents less of income. What does he do with what does he do now? He would reduce his purchase of meat from the butcher. By how much? He would reduce his purchase of meat from the butcher by 90% of that 90-cent reduction in his income, right? So he would buy that much less meat from the butcher, and the butcher, with his reduction in income, would buy that much less produce. And this goes on then forever. But do you see what's happening here? You have minus signs all along because with that reduction in people's incomes, because government's charging higher taxes, you have this big contraction in AD that's going to happen. Right? Now, could you add up this series? These are all negative numbers, but you can get rid of that negative quite easily by putting a negative sign like this and then putting big square brackets and then making all of these positive. Right? Now, how do you add up the sequence of numbers inside the square brackets? Come on. We have a formula here. Isn't this a converging geometric series to infinity? Right? What's the formula for adding this up? Come on, tell me. Big minus sign, and then? What's the formula? Come on. Isn't that the formula? Let's apply that. First number of series divided by 1 minus factor of the series. Right? So what's the first number of our series? That's the first number of our series. So 0.9 divided by, what's the factor of the series? What's the factor of the series? Come on. .9, isn't it? And if you remove those square brackets, you basically write negative 0.9 divided by 1 minus 0.9. Yes? And what is the general form for this? The general form for this is negative MPC divided by 1 minus the NPC. Right? Before I proceed here, if you look at the sequence of numbers inside the square brackets, how would you compare that to the sequence of numbers we had when government spending increased by $1? How would you compare this to this sequence here? What's missing? What's the difference? This is the sequence of numbers here that we got when government increased its spending by $1, right? Could you compare that to what we have now inside those square brackets? What's the difference? The 1 is missing, is that right? The first 1's missing. Correct? This, of course, means right away that the tax multiplier, which is what this is called the tax multiplier. This tells me right away that the tax multiplier is a smaller multiplier in absolute terms. It's a negative number, firstly. But even if you ignore the minus sign, the tax multiplier is going to be a smaller number than the government spending multiplier. Is that right? Why? Because that first 1's missing. Is that right? How would you define the tax multiplier again? How would you define the tax multiplier in words? Tax multiplier is the change in aggregate demand from a $1 increase in taxes. Right? Okay. Let me give you a little problem here. Say there is a recession. And if there's a recession, what should the government do to taxes? Raise them or lower them? If there's a recessionary gap, what should the government do? Raise taxes or lower them? Lower them, correct? Because the government wants to shift the AD curve to the right. And the way to do this is by lowering taxes so that you and I have more income to spend and we go shopping more. Because the idea is to stimulate demand in the economy, right? So let's say that the government cuts taxes by $90 million. Let's say that the marginal propensity to consume is 0.6. Could you calculate the change in AD? Taxes are going down by 90 million. But remember, 90 million is simply 90 million single dollars. Correct? So what formula would be used here again? Change in AD equals change in taxes times what multiplier now? The tax multiplier. Because the tax multiplier gives you the effect of a single dollar change in taxes. But now we have a $90 million change. So that has to be treated as 90 million single dollars. Correct? So if you apply this formula, what do we get? What's the change in taxes? What's delta T? What is it? What's delta T again? Come on, I need somebody to say something. What is delta T? Minus 90 million. Delta T is minus 90 million. Why minus 90 million? Because taxes are going down. Is that right? So minus 90 million times, what's the tax multiplier equal to? Tax multiplier, remember, is negative MPC divided by 1 minus the MPC, which we've established in our previous slide. So what is that equal to then? Negative 90 million times negative 0.6 divided by 1 minus 0.6, which is negative 90 million times negative 0.6 divided by 0.4. Right? And you can write this as negative 90 million times negative 6 by 4. Just use your calculator if you like. Or 3 by 2. Or 45 times 3. Plus. Why plus? Because you're multiplying two negative numbers. Is that right? So clearly it shows here that when taxes go down, the effect on AD is a positive effect. There is an increase in AD, which makes sense. Right? So this would be the effect of the tax multiplier. Now just bear in mind that the absolute value of the tax multiplier, the absolute value of the tax multiplier, the absolute value, meaning ignoring the minus sign, is smaller than the value of the government spending multiplier. Which means that if the government wishes to increase AD by a certain amount, it will have to reduce taxes by more than it would have to increase government spending to get the same effect. Am I making sense? A bigger reduction in taxes would be needed to cause the same increase in AD that a certain increase in government spending would bring about, because the tax multiplier is a weaker multiplier. Is that making sense? Let's now go back to our first slide when we were talking about the increase in government spending. But now, Let's say that the Federal Reserve Bank causes the interest rate to fall. So this is what the Fed does as part of its monetary policy. So this is part of the Fed's monetary policy. And this lowering of the interest rate causes investment spending to rise. We've discussed this in class, am I right? When the interest rate falls, businesses are more likely to buy new machines. Why is that? Well, one simple reason is businesses often borrow money with which to buy machines. If you make the terms of that borrowing cheaper, if you lower the interest rate, that's more likely to encourage businesses to then take out these business loans to buy machines, right? Okay, so let's say the Fed lowers the interest rates and that stimulates investment spending in the economy. And let's say that investment spending rises by $1. So instead of G going up by $1 here, I'm going to change that to I goes up by $1. Would there be any change in this discussion, in the discussion that follows? If investment spending goes up by $1, could you calculate the change in AD? So businesses spend an extra dollar on new machines. Well, that dollar is a part of AD because investment spending, is a component of AD. Am I right? AD consists of C, I, G, and X minus M, right? What the four shoppers spend. So when investment spending goes up by $1, since I is a part of AD, right away you have this $1 increase in AD. Is that right? So that would be the direct effect. So I'm going to put it like this. I goes up, that directly causes AD to go up. But would there also be now an indirect effect? What happens to that dollar that businesses spend on new machines? It goes into the cash register of a company that makes machines, right? Where does it go from there? Into the pockets of the workers who work in that factory. And what will these workers do with this extra dollar of income? Spend all of it or a part of it? The MPC part. They would buy bread from the baker. The baker then would buy meat from the butcher. So you have the same story, basically. Is that right? So you have exactly the same sequence of numbers. And if you add them up, what do you get? You get exactly this. In other words, you get exactly that. So therefore, I would say that this 1 divided by 1 minus MPC is the government spending multiplier, right? But it is also the investment spending multiplier. The investment spending multiplier has exactly the same value as the government spending multiplier because exactly the same thing happens. You have the same geometric series to inflate. So we have established 3 multipliers so far, right? Government spending multiplier, tax multiplier, and the investment spending multiplier, right? And with that, we will stop here.